So, Peter, how many doubling to a billion?
30, pal.
30. That's exactly right. 30 doubling. So I want to talk to you about manufacturing the future. And Peter kind of stole my thunder. I wanted to tell you that it's, we're an overnight success, 30 years in the making. Actually, 31. So, and we're on the verge of reaching a billion, we hope next year. That's kind of where we see ourselves in terms of trajectory. And the man that invented it all, Chuck Hall, his idea was that he's going to help Detroit design and manufacture better cars in 1983. That was his entire passion, was to compress time to value and time to market and to return competitive advantage to engineers in Detroit that at the time, you might remember, were struggling to compete with the Japanese. This was Jeff Immelt. He was talking about why General Electric selected 3D printing, and he was talking about the fact that you can build parts from the ground up. The lead time is shorter, the cycle time is faster, and you end up building what you really need from the ground up. The reality is that there are companies all over the world that are investing billions of dollars in this technology because they're beginning to understand that 3D printing and additive manufacturing is going to disrupt and transform business models, manufacturing processes, supply chains, and the way that we learn, communicate, create, entertain, attire ourselves, decorate, and it will bring about a completely new type of literacy, which is digital fabrication. The opportunity that we have in front of us is to completely disrupt business models, to disrupt distribution channels, to disrupt merchandising and retails in a way that we haven't even conceived of before. And it's going to touch every part of our lives. And 3D Systems is a company that is looking at this not just in terms of how do we bring about the output device, but what we're really passionate about is how could we democratize access to this technology in ways that starts with how we communicate about design or how we communicate with our design tools. So think about how we design today. We work on a keyboard. We can hit some of the keys. We can click on the mouse. If we're lucky enough, we may actually have some more sophisticated perceptual design tools like haptic devices, which we, by the way, make, that allow you to actually touch the design and feel it and get haptical force feedback so that you can begin to play with your design as if you were modeling and patterning in digital clay. Oh, wow. Let's see. We're back.
We certainly wouldn't be able to manufacture the number of components, the complexity levels that we do using stereotypography at this time.
The business case for the use of this technology is just phenomenal. It is a way to reduce product development time, saves costs, gives designers more options. I don't see any end in sight for the use of this technology or General Motors' use of this technology.
And 3D printing allows you to make that product right the first time. It allows you to make it from the core up. So you basically don't have as much waste. The tooling's cheaper. The cycle time's faster. And that is the holy grail. So if I thought all 3D printing could do was your shoes, I wouldn't be talking about it quite as much as I am today. But if you can make unique shapes with high-tech materials in a quick period of time, that is worth my time. That is worth a lot of investment.
So Immelt doesn't want to talk about shoes, but that's all Nike is talking about. And in the case of Nike, they just did all the cleats for Super Bowl, and they're beginning to roll this into other advanced applications because for the first time, they can optimize performance to your body. They could begin to register and record and biomimic and amplify and multiplex your personal performance. What's the big deal about 3D printing at the end of the day? It fundamentally boils down to the fact that with 3D printing, complexity is free, which means that for the first time, you can begin to design for performance and function and not to the traditional constraints of manufacturing methods, which limited you in all the ways that you could manufacture so that you could mass produce. Now, I used to think that since complexity is free and there is no penalty anymore, there is no burden for complexity, we would usher in a completely new era of mass customization, personalization, and stylizing. And to a certain extent, that is happening. But what I did not foresee is that it would also usher in a completely new era of mass manufacturing of identical but very complex parts, as GE is doing. And when you look at how big this could become as part of a $70 trillion manufacturing economy, it's important to think that there are really 4 trends that are driving adoption here. The first is that design and manufacturing will be completely reimagined. The second is that free complexity will drive enhanced functionality and performance. The third is that it will completely revolutionize personalized surgery and patient-specific medical device in ways that would completely alter outcomes, and the fact that it will usher in, finally, a 3D lifestyle in every way.
I've been paralyzed for 22 years with no sensation or movement below my pelvis. What defines a person? What if technology could improve your quality of life, give you freedom of mobility, but also become an extension of your senses? The bionic exoskeleton, or wearable robot, has come to represent a true technological biological fusion as the most complicated neuroprosthetic ever imagined. Design engineers from 3D Systems teamed up with Bionic to create the first hybrid 3D printed exoskeleton. I became an integral part of the design process. I was dressed in a skin-colored unitard as the team scanned my body while I was sitting and standing in the robot. These images were then cast onto a computer screen. The goal was to create custom 3D printed parts that connected my body accurately and symbiotically to the robot. These fixed interstitial parts needed to envelop my legs and torso in exact locations to provide balance and support while carefully avoiding pressure points. The 3D printed parts are strong enough to hold my body in various postures, yet flexible enough so they're comfortable. They're ventilated with a complex striated filigree pattern resembling my muscles. These parts allow my skin to breathe, yet the product weight is minimized. For the first time, I feel as if the exoskeleton is truly one with me. It's as if it's an extension of my body, as though my own DNA has been imprinted into the design itself. An exoskeleton can become so much more than enabling a person to walk again. It can become an art form of moving sculptured beauty reproduced from a person's own blueprint. A paralyzed man or woman can look forward to being beautiful, standing tall, and walking again in the ultimate fashion statement. That's a 3D printed exoskeleton that reflects who they are on the inside.
What do you think? So Amanda is a good friend of mine, and she challenged me to do this actually at a Singularity event almost a year ago in Los Angeles at Fox Studios. And as soon as I delivered this to her, which was a while ago at another Singularity event in Budapest, within 5 minutes, you know, after the hugs and the emotional celebration, she said to me, remember, I'm a woman. I want to be able to strut my stuff. I want you now to make it really part of me. And by the way, I want to be able to walk in high heels. Yesterday, we announced a new scoliosis brace for girls. The #1 problem with scoliosis for girls, which are about 90% of the demographics, is compliance, because it's cumbersome. And when they don't comply, it leads to corrective surgery, which is even more painful and torturous. So you can see some examples of 3D printed fracture brace, scoli. But what you don't know is that already today, on an annual basis, nearly 20 million Invisalign aligners are manufactured using our 3D printers. And every in the ear canal hearing aid device today around the world is 3D printed using biocompatible materials. Increasingly, patient-specific full knee replacements are being 3D printed. And what's even more amazing is that all of the surgical instruments, the way that it's guided and planned, are made from your data, 3D printed, sterilized, and delivered to the operating room, made for you, eliminating all of the guesswork. Companies like GE are spending billions to save millions of dollars in fuel consumption on their next generation LEAP engine. And that's good for GE. It's good for the environment. It's good for the airline industry. But what you don't expect is that startups like Peter's Planetary Resources are also using 3D printers, and they have access to it to make their, what I call the space drone that is going to go out there and get us some resources from near-Earth asteroids. And they can do it cheaper than NASA. They can do it faster. And it actually shows us the power of democratization, where you expect GE to do it, you may not expect a startup to do it.
Do you think 3D printing will ever be faster than injection molding?
Nope.
Will 3D printing ever, in a million years, be faster than good old injection molding?
Not a chance.
In the last 140 plus years, injection molding has become the process of choice for bulk plastic manufacturing. Even with all the promises of 3D printing, industry observers have asserted that it could never be as fast as injection molding. I'm here at 3D Systems to break the news to them. 3D printing being faster than injection molding, that's definitely fiction. I'm here to be. Thanks.
If you plot out the build speeds of 3D printing over the last 20 to 30 years, what you'll find is that it's continuously got faster. And if it continues in this trend, we're going to see more and more lean, same-day, on-demand manufacturing coming from 3D printers, a true alternative to injection molding.
Yeah, right. How could that even happen?
Lots of R&D, better materials, more powerful lasers, bigger machines. It's more smart work. We're doubling 3D printing capabilities every 18 months. This has been happening for over 10 years, and it continues to do so. Injection molding systems, on the other hand, it's leveling off. It's a mature technology, and it's not getting any faster.
It's some kind of joke.
Let me give you an example. We recently printed 2,400 mini lampshades on an SLA machine, and it took about 20 hours. That's 30 seconds per part.
Plus, with 3D printing, you don't have to wait weeks for tooling. You can easily iterate designs. You can be manufacturing faster.
Is this true? "3D printing is that fast?" 3D printing is that fast. It's a fact.
So I saw lots of raised hands when Peter asked you how many of you knew about 3D printing. How many of you knew that you could print a part every 30 seconds? Only the two smart guys in the room. So 3D printing technology is advancing very fast. It truly is exponential in every way, and that includes the number of materials, including the ability to print in real ferrous and non-ferrous metal alloys in ways that actually exceed the performance of investment casting parts and CNC machine parts. And this is only the beginning.
That's why I do this. I love my work. I love my craft. I love closing my eyes and seeing where the forms and turns of every ring or cufflink takes me. But I have to make those designs real. That's the business part. And before the ProJet 1200 3D printer, making it real was like making a compromise. It felt like I had to shush my imagination and focus on manufacturing. Now I go into every piece knowing that if I can design it, I can make it, period. Press a few buttons, walk away. And within an hour, I've got a 3D printed casting pattern that matches my design perfectly. I can go straight into casting. It sounds easy because it is, and at a price that I can manage. That's how my creative...
So desktop manufacturing is becoming a reality. For under $5,000 now, you can print your wax-ups, and you can go to precious metal casting as a jeweler. Same for the dental industry. Desktop manufacturing is a reality. And I am absolutely passionate about making sure that the 3D lifestyle happens. And in my mind, there is no question of whether or not we will have a 3D printer in every home. The right question to ask is, what room in your house will your 3D printer reside? Is it going to be in your wardrobe because you will accessorize what you're going to wear with your evening attire? Is it going to be in the kitchen because you will be printing personalized nutrition? Is it going to be in your man cave, maybe, if you want to pursue your hobbies? That's the way that I'm looking at it. And you can see that this is going to be complemented with ubiquitous physical photography devices. The techies call it 3D scanning. I call it physical photography. And we already have devices like this on the market for under $400 that will completely digitize you and replicate you. And of course, the same tools will become perceptual design tools that will allow us for the first time to communicate and create designs by looking at gestures, at haptical force feedback, at facial expressions in the same way that I'm communicating and making eye contact with you. And that's another way that we're going to mainstream it to the other 99% who are not going to become CADers and coders anytime soon. That technology is real, and it's being commercialized as we speak. And you can see some of the early applications that will allow us and startups to completely disrupt existing business models. I mean, ask yourself, when was the last time that you saw any innovation in eyewear frames? In fact, ask yourself how many of you, well, let's see, how many of you know your shoe size? How many of you know the distance between your temples? Anybody? I didn't think so. Oh, you do. You know everything, Brad. These kinds of capabilities are coming to the market because of the digital thread that connects all these technologies, and it's going to increasingly become faster now.
Those who produce high-quality, personalized products at breakneck speed win. 3D printing has already begun to fulfill this promise with its ability to produce customized, complex, end-use products. Now with 3D systems, we're adding speed to the equation by putting the capabilities of 3D printing on the fastest track yet. The paradigm-shifting, continuous, high-speed fab-grade printer will make true automated, low-touch, additive manufacturing a reality. To ramp up the speeds for production-level volume, we've broken away from the methods of contemporary 3D printers. Typically, they utilize a movable print head or laser, which creates layers on a stationary print bed. But we've created a true assembly line for 3D printed products by making the print bed mobile and the print head stationary, all in a speedy racetrack design. Production volume capabilities of this magnitude coincide perfectly with Project Ara, Google's initiative to create an open hardware modular cell phone. Project Ara makes the cell phone a pure personal expression, but to see it through, they need the capability to create thousands of unique module shells every day. This is round-the-clock, customized, complex part production at its finest. Parts in minutes, no labor required. Highly scalable, the Project Ara engine's first prototype and test beds are coming to life as we speak. But this capability goes far beyond cell phones. This is the road to high-speed custom manufacturing, and it's even closer than you think.
So a few minutes ago, I told you that we can print parts at a rate of a part every 30 seconds. Our partnership with Google to help them manufacture the Ara block phone will take that and advance it 50 times. So we're talking about a 50x improvement in speed and the first ever continuous 3D printing assembly line that will print in multi-materials, vibrant colors, and conductive layers. Think about the possibilities when you begin to create composites that can also have conductive layers and intelligence, and where that takes us in terms of further functionality. And think again about what happens to that $70 trillion manufacturer industry, even if we can just grab 1 or 2 percentage points and begin to disrupt it.
Welcome to the Sugar Lab.
The Sugar Lab is 3D Systems' digital bakery that uses 3D printing technology to print with sugar.
I'm Liz.
I'm Kyle. We both have a background in architecture. We bought our first 3D printer during grad school.
Then one day we printed a sugar tiara for a friend's birthday cupcake, and she loved it so much that it really got us thinking. Maybe this could be a whole new territory for 3D printing.
So we kept experimenting with sugar. We deliver to people in LA who can order online.
In 2013, we became a part of 3D Systems.
We started testing out new recipes and creating more elaborate shapes. But sometimes, nature inspires the best designs.
So instead of modeling a 3D design from scratch, we can actually use the Intel RealSense 3D camera on our 2-in-1 to capture the geometry we want in 3D.
I love that any idea we have can be made into a reality.
The technology is ready.
So when we speak about making it ubiquitous through partnerships like the one that we have with Intel, we're basically gamifying the ability to create content and allowing people to replicate and enhance and personalize and stylize. And all of that comes with what I call the digital thread, which is the pipe that connects us from ideas to physical matters, from virtual to actual in ways that are relevant and concrete. So I want to close with this.
Layla could not breathe or even swallow. She went straight into the intensive care unit. J-Lo was born with a rare condition where the jaw is so small the tongue is pushed back into the throat and prevent breathing. Normally, these children must wait until they're big enough for surgery, which can mean 6 years, with a tube through the throat to allow them to breathe. But J-Lo was spared that thanks to a new technique which allows surgeons to plan a difficult surgery ahead of time on a 3D model instead of the patient.
The advantage of 3D technology is that you can actually do surgery before you get to the operating room. So it not only allows you to plan the surgery, but pick up any problems that might happen during surgery that you want to avoid.
You see, often with complex spatial trauma patients, bones have shifted so much that doctors don't have typical landmarks and reference points during surgery. They're essentially making decisions based on guesses, which means lots of trial and error. During a virtual surgery, doctors make all their mistakes on the model, planning the surgery step by step before they ever make an incision.
What you're seeing here are the early tooth buds, as well as the nerve, which is running through the bone, which supplies sensation to the chin and the lower lip. And we certainly want to preserve those structures.
And in one shot, the surgery was a success.
She had all this energy. A week after the surgery, she was still intubating, but she was more aware.
Then, twice a day for 1 month, Dr. Tepper and his team would tighten J-Lo's screws just a little bit.
So all of this is under the skin. And with one turn of the screwdriver, it turns 1 millimeter, it advances 1 millimeter. And so here you can see those pieces begin to advance.
They said that she might feel uncomfortable, but she didn't fuss or anything.
Instead of 2 or possibly even 3 invasive surgeries on a baby barely 1 month old, Dr. Tepper was able to fit the device to J-Lo's jaw during his first attempt. Less cutting meant less pain for J-Lo and a faster recovery. Within 3 months, the device was removed, and J-Lo could finally start using that smile.
She's doing great. I didn't think she was gonna be the way she is. She's so hyper. She's into everything.
So 3D printing is going to change everything. It's one of those crazy ideas that, as Peter often says, 5 minutes before it becomes ubiquitous, it's crazy, and 5 minutes afterwards, nobody knows how could we have ever lived without it. It's changing everything. Last year alone, we delivered over 10,000 VSP procedures in a variety of head and neck operations. And each one, without a fail, was completely successful.
Hi, my name's Sally. I'm the founder of pedalpetals.com. And let me tell you how I went from an idea to a product in a day. About a year and a half ago, I had an idea for a bicycle accessory. It was a simple silk flower and a clip. At breakfast time, I had an idea for a bicycle accessory. By about 9 a.m., I was designing on CAD the clip. By about 10 a.m., we were printing the clip on the 3D Systems Cube printer. I went straight downtown LA, the flower district. I bought a beautiful array of different colors, flowers and lotus flowers and daisies and lots of different variety. By about 2 p.m. I was back home. We had the clip and the flower. We put them together, took the photographs, put my pictures uploaded on Etsy on the seller's website. By about 6 p.m. I have my first order. So I went from an idea to market in a single day. So the next day when all the orders came in, I had to figure out a way of how I was going to fulfill these orders. So I uploaded the CAD file to Cubify.com, placed a larger order, and within 48 hours I had a whole pile of clips and I was able to fulfill all my orders, and now I've got lots of happy customers.
So when you think about time to value, when you think about time to market, when you think about how your business could be disrupted or how you could disrupt others, remember that it's already happening. Thank you very much.